Hello there. We're in sunny Tucson, Arizona, and it's pleasant low to mid 80s. It's been 90s through the weekend. We've been here since Friday. Really enjoying our vacation, and so it's hard to get back into teaching Algebra 2, but we'll give it our shot, give it our best shot here. So I'm going to jump right into it again. Video coverage or video footage is this camera. I don't know how much battery it has on it, so we'll jump right into the lessons here. So we're on lesson 113, and actually these 4 lessons today have a lot to them. So hopefully we'll be able to get through them all. Lesson 113 is logarithms and anti-logarithms. So what is a logarithm? Logarithm is essentially the exponent, and I guess a lot of the book mentions that folks have difficulty with logarithms, mainly not because what they are is complicated, but just the naming of them and how getting confused on what's the exponent and that sort of thing. So let's look at the example here. So if we have 10 squared is equal to 100, this part here, the 10, is considered the base, and this here, the power, the exponent, is actually the logarithm. And then there's actually a name for the result here, and that is the anti-logarithm. So in this lesson, there's basically just 3 components to it, and we also learn about e, and when you raise e to a power, let's say e cubed, what is e? E is actually, I don't know if they define it in this lesson. Let's see here. Yeah, they don't define it. The number e. E itself is approximately 2.71828, and then it continues on. So it's actually a irrational number. And e cubed, this would actually be considered, anytime you raise e to a power, this is considered the natural logarithm. So you actually, with a logarithm, you can have any base value. If the base is 10, that's considered the common logarithm. And so if you put in a logarithm function on your calculator, it's typically going to be base 10. If you have base e, that's considered the natural logarithm. So let's go ahead and erase this. And it's going to be a little bit awkward here. And actually, hey, it erases. So we switched sides of the trailer. The other side, we have yet to find something to clear off the markers from that side. We've tried a couple different products, and nothing seems to be working. So, but we did find that these Rosart markers, what makes this, I don't know who that is. Anyways, they're not a dry erase marker, but they wipe off of a trailer easily. So, well, relatively easy. Actually, they didn't quite come off. Okay. So let me pull out my laptop here. So I took some notes here. So the way we write this is kind of backwards thinking as far as, we wrote 10 squared equals 100. If we look at the log base 10 of 100, this is basically saying, here's our base 10, 100 is the anti-logarithm, and so what is it we're looking for? We're looking for the log, which is the exponent. So 10 raised to some power is 100, and that power is 2. So you might see it written log base 10, or you might just see it written log 100, because the assumption is it's the common logarithm, which is base 10. And very rarely you're going to see a logarithm of something other than 10 or e. And so log of 10 here is 2, same thing. The other, we mentioned e, so if you see log of e, an example here, yeah, not an example. Yeah, so they say, let's say what is the log of e of 105? Well, we're looking for the power of e that gives a result of 105, or the anti-logarithm of 105. And because I can't come up with that in my head, look at the book here and they use the natural log button in their calculator, and they get 4.6539. And it continues on. And so you might see it written this way: log of e of 105 is 4.6, or you might just see natural log, which is ln 105 is equal to 4.6539. So a couple different ways. This is probably the more common, but you might see it written this way as well. Okay, so let's see what else. In Excel, if you don't have a scientific calculator, because you might find that handy if you don't have, if you do have one, you don't have it with you, or you just don't own one. What is this in Excel? There might be some multiple ways to do this in Excel. I found a couple different ways. Yeah, this is going to take up a fair amount of video to do all the wiping here. Okay, so then we have when the little breeze is out here to deal with. So challenging. Okay, so in Excel, if you want to write the common logarithm of base 10, so it's L O. Well, first of all, with functions in the Excel cell, you actually have to put the equal sign to represent that you're going to put in a function. And if you do log 10, and then it wants, basically you feed it the anti-logarithm. So, for example, log 10 of 100, and if you hit enter, you're going to have the result is 2. And let me make sure that's okay. Making sure. Okay, so that's the common logarithm. If you want to do the natural logarithm, I didn't really explore around all the functions, but I did find that if you do equals log, and then if you just do log, it's going to ask you for the base, and we'll give it the base of exp, which is e. So you have your anti-logarithm, and in this case, we'll take the example of 105. There's our anti-logarithm. And then you do this, comma, exp, and it wants to know the power of e. And if you give it the power of 1, you're just basically saying e. So this basically is the same as writing log e of 105. These are equivalent in Excel. And of course, this will give you 4.65 on and on. And then as far as anti-logarithm, I didn't really talk about how you do that on a calculator. There's an inverse. Some calculators have an inverse. So you hit inverse and then logarithm. That is the anti-logarithm. And let's see what. I'll give an example here. So in Excel, it's not as elegant. I just basically said you give the power, equal power, and then parentheses 10, comma, and then whatever logarithm or exponent that you want it to be. So let's say 2. We're basically saying raise 10 to the power of 2, which gives you 100. And similarly, if you want to do anti-logarithm, anti-natural logarithm, you can say power and then exp to the power of 1, comma, and then your logarithm, which we said was, if you put in 4.65, and that give it enough significant digits here, 4.6539. You can continue on as much as possible there, or you can actually put in this guy here into this space. Should give you back 105. So these are Excel, again, if you don't have the scientific calculator. Okay, so let's jump into examples. Example 113.1. Okay. So it says use your calculator to get a value for E. Okay. So how do, we're running into a problem. Purple does not erase. We'll go back to brown. This is quite challenging. We will stick with brown. We're going to have, by the end of this trip, we're going to have Algebra 2 all over this trailer. whatever dye they're using in the ink. It's, only brown is the only one that comes off all the way. Okay, so how do you get, so e to the 1 is equal to e, so if you're trying to use a calculator to come up with the approximation of e, if your calculator has a natural logarithm function on it, then you can use that. So you put in the 1, and then you give it the inverse button followed by the natural log button, and that'll give you the approximation of 2.718 and so on. So that was example 113. In Excel, we'd want to use the inverse, which is the anti-logarithm. We still have the purple in the background here. So it'd be this guy. So we'd say equals power of exp1, comma, and then 1. And this should give us 2.718. Is that right? So, yep, we're basically raising e to the 1. Or you can just say equals exp1. Same thing, actually. This is redundant here. Okay, let's see, example. Let's get into some a little bit better examples of what you can do with these that are more applicable, or more, what's the word? Useful, perhaps. Okay. So it says use base 10 logarithms to simplify 47,832 multiplied by 59,463 divided by 0.000817. So the key to these is to get all these values to a base 10, and so what we'll do is we'll basically calculate the anti-logarithm of these. I'm sorry, saying that wrong. We'll use the log key to find what is the power of 10 that each of these values are. So for example, we're saying 10 to the x is equal to 47,832. What is x? So that's the goal, and we want to represent each of these numbers as a power of 10. So the way we do that is we use the log button on your calculator, or we can use the log function, log10 function in Excel. So log of this number here ends up being the power that we want. So we have 10, and I'm going to look at the book of what they came up with. So for this number, the power was 4.68, and then this was 10 to the 4.77, and then for the denominator, we have 10 to the minus 3.09. So now we have a common base, and then we can just simply combine the exponents using the power theorem. And so here we add these two, and since this is a denominator, it's a negative, so it's a negative negative, so it ends up being positive. So we have 10 to the 4.68 plus 4.77 minus a minus 3.09. Add all these up, we get 10 to the 12.54. So by simply plugging this value in, hitting the log button, we get the power base 10, and we can convert them all to a base 10, and then we can combine the exponents. So that's the example there. And let me see if there's any other. 13.4. Yeah, I'm going to skip that one and move on to the next lesson. So that's it for lesson 113.